Hi students, welcome to Year 11 Biology, and this is module number 4, Ecosystem Dynamics. We're at video number 9 and we're going to focus on ice core drilling. In this video, it's our intention to again analyse paleontological and geological evidence to provide evidence of past changes in ecosystems, including but not limited to ice core drilling. So, in simple terms, what we're going to try and do is see what information we can collect from ice cores, where we do collect those ice cores, and what sort of information that they can tell us about what may have been going on in the atmosphere in the past. The three potential levels of success that you can have in measuring your own level of understanding at the end of this video, and certainly at the end of the series of work, is that you can link ice cores to past environments, that you may be able to draw some conclusions about past environments from specific ice cores, and also to use ice core drills to discuss evidence for things like changing global climate. Extrapolating data from what we already see can give us an idea of how the environment has changed in the past and potentially the sort of things that may affect the environment going into the future. So what are ice core drills? Well, this is an ice core drill. When ice freezes, it can trap gases and particles from the atmosphere, and ice does not deposit in equal amounts over time. Some years are warmer than others, and therefore there is less ice. Other times there may be cooler years, and so there are thicker layers of ice. So just like tree rings are often used to give us a bit of an idea about the age of a tree, but also the sort of conditions that may have been present as that tree was growing, we can also do a similar sort of thing with ice. Obviously, the most consistent records and the ones that go back for the longest periods of time in terms of looking at ice cores are the poles. So both the Arctic and the Antarctic have permanent ice, and so we can therefore dig through into different layers of ice. And just as when we go further into the ground and look at different types of rocks, we can go further back in time, the deeper we go. The same is true when we're looking at ice cores. The thing about the poles is that the ice has been accumulating for very long periods of time, and so they give us a nice little window into the past. But what sort of information do they contain? Well, hopefully one of the things that we can do is we can look at gas particles that may be present in the ice. And if we can extract the gas particles and analyze the gases that are present, we may find consistency between the levels of important gases that are present from past environments to what they are now, or we may find differences in some of the levels or proportions of different gases in past environments to what we have now. And of course, if the latter, then that gives us some information about the changes that may have occurred and allows us to start to infer reasons of why those changes may have occurred. So analysing samples from ice cores helps us to build a bit of a picture of the change in levels of important gases. And one of those gases that's obviously very important discussions around climate change are the levels of carbon dioxide. Antarctica provides ice core data for about 800,000 years, and the other area that's probably most studied is Greenland, but obviously that's a long way from Australia, so Antarctica is the one that we want to have a little bit of a look at in this video. Annual layers, as I mentioned before, help with dating the ice, so we can look at each of these different layers laid out over long periods of time, and the fact that the ice gets thicker or thinner depending on whether the climate is warmer or cooler. And sometimes we also find some really important things in the ice that can tell us additional information, or at least give us confirmations about what we're thinking in terms of age. Volcanic ash is particulate matter, and this can actually get caught up as a volcano erupts. It can throw ash, lava and all sorts of things into the atmosphere. That ash can then float around and perhaps settle on the ice where it can then be trapped. And that ash can contain certain types of radioisotopes that may be possible to help us to date that particular sample of ice. Now, in order to do this, we need to take thin slices So this is where we go from a core that's been pulled out with a machine that you saw in one of the previous slides. This is what the core actually looks like. And once we take a sample of the core, a thin slice of that core, then we get a particular section that we can analyze. And as I said, we're looking for gas bubbles, and we're also looking for particulate matter that may be able to help us to not only age the sample, but also to determine the concentration of any gases that are present. In her outstanding series of books, Blitzing Biology, Katrina Garner has produced a couple of really nice graphs, which I have taken for this particular video, but with acknowledgement, of course. And this shows you some of the sort of data that we can gain from the ice. Now, it's very important when you're analysing graphical data that's been obtained from ice cores that you look very carefully at not just the scale or the label for the axis, but also the scale. Where is it starting from? What's happening with those values? Whenever we're looking at graphs, of course, we're always looking to describe and explain. So when we look for a trend, and you can see that there is a cyclic trend here, the levels go up and down, so we get this fairly regular up and down movement of the temperatures increasing and then decreasing. Now, it's not smooth. There are a lot of jumps that are happening in each of these, but we can see some overall trends. We also want to look at and see if there's any data in here that's actually telling us something slightly new and slightly different. And so when we look at the second of these graphs, the carbon dioxide concentration, we can again see that there's some parallels between the cyclic nature of the carbon dioxide concentration and the temperatures. So there does seem to be a little bit of a relationship here already between carbon dioxide and temperature change. Now, that in itself would be fine, and it's a fine description to talk about that, and maybe you can even explain the link between increasing levels of carbon dioxide in the atmosphere and increasing global temperatures. But what's very interesting, and one of the things that that Garner has put into her book is some questions about the current levels of carbon dioxide and how they compare to the maximum levels that have been measured from ice back in the past. Now, I think that's an absolutely fabulous activity to do, and so I'm not going to spoil it. I think it's important that you have a look at her resource and work through that activity. But you can also get up-to-date numbers on carbon dioxide concentrations from several sources around. And what you do notice is that there's some unprecedented levels that we're seeing of carbon dioxide level in the atmosphere. What does that mean, and how do we interpret that? Well, they're very important questions, and of course they're part of the scientific process, and obviously one of the things that's really important is to do a bit of deeper analysis of these types of graphs to see what sort of information we can get about past environments from ice core drills. Good luck with it, and thanks for watching.